Welcome to SDN Tech Forum. I'm starting a new video series on especially on telemetry or model-based telemetry, which the feature which is available on most of the Cisco IOS-XE, IOS-XR and NXOS routers. This feature is a combination of a couple of protocol suites which are like standard RFC based and some open source tools for visualization and all. So here on my screen you can see that agenda for this series is we go over multiple protocols like Netconf, Yang, Restconf, gRPC. gRPC is fairly new, and then understand what is model based telemetry, and then I will show you a demo how to enable Netconf and telemetry on Cisco devices, and finally we'll explore some of the tools which can leverage these protocols, RFC based protocols, to talk to our network devices, and Yang Explorer is one of them. So I'll show you the Yang Explorer demo. This video I'm going to mostly talk about the protocol in theory, so before we go ahead and do implementation. So the first protocol is Netconf. Netconf is not a new protocol. It's been there for quite a long time, but adoption of Netconf has not been that popular initially because of the lack of development effort, and a lot of devices, implemented devices in customer base, they were not Netconf capable. But now, so most of the with software upgrade, this Netconf capabilities started getting introduced into Netconf. So my first protocol here is Netconf. Netconf is protocol defined in IETF to install, manipulate and delete the configuration of network devices. So it was created keeping in mind like it's going to be an alternative for the CLI, because CLI may change from one release to another release, and every vendor has their own CLI. So the motivation behind was to have a standard protocol which can basically talk to all the devices, which is being vendor neutral. But given said that it was not that easy to come into agreement of like having one single language. But how Netconf works is Netconf relies on the top of RPC layers using XML encoding and provide a basic set of operation to edit and query on network devices. So you can think of it like SNMP, get and set operations, capability exchange list available, and underlying of Netconf is a Yang data model. So Netconf and Yang goes hand in hand. Yang is a data modeling language for Netconf. Yang model within IOS-XE devices have been defined that how to structure the data to send and receive. So how you can structure your data when you're talking to network devices and when you're receiving the output. It is again a RFC published 6020. There are two main types of Yang model, native and open. The model are further categorized as either configuration model or operation model. So configuration model is like when you want to change something, and operation model is like more like a get commands or a show commands. So I want you to look at this picture. Mostly what we will be talking during this video is on the protocol layer. You can see Netconf, Restconf, GNMI, gRPC. These are certain protocols which you can use to talk to your network devices. Then we have a Yang data model, which actually formatize how you're going to configure your devices, how you branch out the configuration, and it's more like a XML structure. So you will see how a Yang model look like. And below that we have devices which are broken into features like BGP, how you want to configure BGP, ACL or any QoS feature. So a little bit on Netconf. Netconf again is IETF standard 6241. Netconf protocol define how to configure network devices and upload data, manipulate data. Netconf messages are encoded in XML. Each message is formed as 1.0 or 1.1. So latest Netconf capability is 1.1. Initially it's 1.0. When you start Netconf on your device, the handshake happen, and you will realize that whether the device is Netconf 1.0 capable or 1.1 capable. The good indication is 1.0 always have this bracket this thing here. I'll show you once we talk to a live network device. Again, Netconf is supported on SSH or TLS. So authentication, integrity, and confidentiality is there. Basic Netconf operations. These are some basic Netconf operation. So hello exchange. Netconf is a session-based protocol. That means before you push any configuration or pull any data, you need to establish a session, and the session is established using hello, Netconf hello. And during exchange, the hello, both client and server, they actually exchange this capabilities. And if capabilities matches, if someone is 1.1 and one is 1.0, some kind of negotiation happen and we settle on the lowermost supported. But in case if there is no overlap between server and client for Netcom support, the session will not go through. So that's very important. Once session is established, you can do get conf like show command. You can say get, that means get everything like show IP interface. You can also edit config. So you can shut down a device, you can push services and all those things, and then you can commit. If you want to kill the session, you can just say close session. And before we go to other protocol, one of the key things to understand that Netconf at the same time runs various databases. That's why when you start editing the config, you are not actually editing the startup config or running config, you are editing a candidate config, and when you actually commit, then it get pushed as a running config. So at the same time, the server holds multiple data stores. In general, they are like running database, startup config database, and candidate config database, as shown here in the picture. How Netconf talk to a network device? You can see that a client, maybe a laptop or a server running a Netconf program. It talks to a Netconf server, which is your Cisco device or any network device which can support Netconf. So client connect to Netconf using SSH. So, once it sends SSH request using a Netconf subsystem, server respond to with a hello, and it lists out all the Netconf supported capabilities. Client in turn also respond to the supported capabilities, and at this point of time, the Netconf session is established. After that, client can issue any Netconf request like a operation or a configuration, get command using RPC, remote procedure calls. And server, if it has those data, or if the RPC is supported, server just reply with the data back. Like if you say show IP interface brief, and if that RPC is formatted correctly, server is going to accept that call, accept that RPC request, and then in turn it says send a RPC reply which will list all the data. Fairly straightforward here. The second protocol of choice is YANG. So you know that YANG is like very fundamental to Netconf. So it's a data modeling language. Configuration data and state data manipulated by Netconf protocol, and it helps you to run Netconf RPC, and obviously for Netconf notification also. A little bit about YANG. YANG is how YANG is structured is like they have hierarchy. You think of YANG like a tree. So on the root you have, at the root level you have some features, and then the features are broken into different attribute which we call leaves or leaf list. Why YANG? Because YANG model is reusable. So you can use, if you define one Yang, probably the same set you can reuse in different trees, and it is very human readable. This is the typical Yang model structures look like. So you can see that module, submodule, and then you have container, and then you have leaf list, leaf. This is how it's broken basically. But once you see a Yang example, you can easily read it. So that's the beauty of Yang. The third protocol, which is again gaining very popularity after Netconf, is a Restconf. Restconf is a REST-like protocol, runs over HTTP for accessing data defined in Yang using data store defined in Netconf. It defined how Yang model is mapped to RESTful interface, support options like so just like Netconf. It has also have different options like get, post, put, delete. It's not exactly same as Netconf, so be aware what is supported in Netconf, what is not supported in what is supported in Restconf. So just be aware of that. And again, it is also RFC standard, but the beauty is it runs on HTTP or HTTPS. That's why a lot of controller or software based application started using Restconf instead of Netconf. Again, on a network device, so it can talk to a Restconf client. You need to enable it on the client itself. So it's a Cat9K, and I'm saying Restconf and IP HTTP server. So since it works on HTTP, you need to enable HTTP. A fairly straightforward configuration here. GNMI is very new, developed by Google. Again, it's a network management protocol. A model using Yang is one of the way to configure. I haven't used it like extensively, but this is very good when it comes to support the data visualization, because Google is very prompt to provide you the pipeline and all those things. So I will touch base upon this when I do a Elastic Logstash and Kibana video, ELK stack video. GNMI is ahead in the curve in terms that you can fetch all the data from devices and do a visualization. And the final thing for this video is tools of trade. There are many tools available in market. I'm not going to name them, but one of it which is available as open source is again Cisco developed protocol, but available for a download and wider use. It's a Yang Explorer, as it says, a GUI driven tool to test Netconf and Restconf interfaces defined by Yang model. So it can help you run your RPC calls, build your Yang model, load your Yang model, and also you can generate self-contained Python script. So it can help you from XML. It can help you to convert it in a Python script. Open source, free to download, very easy to install. I have pasted a link here, so you can do a git clone and then just go to your Yang Explorer directory and start the functionality. And once Yang Explorer is started, you can access Yang Explorer using localhost. It works on protocol 8088, and then it bring up the GUI interface of Yang Explorer. I will give you a demo how to work with Yang Explorer in upcoming video, and also we will see how to enable Netconf on a Cisco device. So this is for this much